Hello, everybody. Happy Friday. Obviously, I am not here today, so I recorded this video of me going through Lesson 9. Hopefully, you were given a handout on your way into the classroom. So make sure you have that handout ready because all I'm going to do is go through this handout here, starting with the warm-up that I have on my screen. So let's take a look at this warm-up. The graph shows the populations of Baltimore and Cleveland in the 20th century. B of T is the population of Baltimore in the year T. C of T is the population of Cleveland, C for Cleveland, in the year T. Explain B of 1930 and estimate B of 1930 and explain what it means in this situation. So B is for Baltimore. So we're looking for the population of Baltimore in 1930. So that's going to line up here. So it looks like population of Baltimore in 1930 was 800,000. So estimate B of 1930, that would be 800,000. Okay. And then, let me use a different color. Explain what it means in this situation. It's exactly what I said. The population of Baltimore in 1930 was 800,000. So we estimated it and we explained what it meant. So that is number one. Number two, here are pairs of statements about the two populations. In each pair, circle the statement that is true. So we're comparing Baltimore in the year 2000 to Cleveland in the year 2000. So 2000 is here, okay? And we can clearly see the blue curve, which is Baltimore, is greater than the dashed curve, which is Cleveland. This is higher than this. So Baltimore in the year 2000 is greater than Cleveland in the year 2000. So we're looking for the one with greater than. That's going to be this statement right here. And then for B, we're comparing Baltimore with Cleveland in the year 1900. So this one right here. So Baltimore and Cleveland in 1900 were definitely not equal. They're definitely two different spots. So is Baltimore greater than Cleveland in 1900? And clearly it is. Baltimore is higher than Cleveland. So this one is true for part B. Number three, were the two cities' populations ever the same? If so, when? Estimate using the graph. So we're looking for years when both cities' populations were the same. It looks like they intersected here. Okay. So they intersected here, and they also intersected over here. So what year was that? So this looks like it's just after 1910, between 1910 and 1920. So you could say 1911, you could say 1912. I'm going to say 1912. Okay. And then the other intersection point was right here. And to me, that looks about halfway between 1940 and 1950. So I'm going to say that I'm going to estimate that's 1945. If you said 1944 or 1946, that would be okay. But that would be an estimate of when the two cities' populations were the same. Okay, so that is our warm-up for the lesson for today. Let's go into the actual content of this lesson. Okay, so instead of comparing two cities, Baltimore and Cleveland, it looks like we're going to compare, looks like landlines and cell phones. So H of T is the percentage of homes in the United States that have a landline phone in year T. C of T is the percentage of homes with only a cell phone. Here are the graphs of H and C. Okay, so estimate H of 2006 and C of 2006. So 2006, okay, 2006 is going to be here. Okay, so we can see in 2006, it looks like, okay, it looks like between 80 and 100. I will say maybe 85% of homes had a landline. And then if we look for cell phones, it looks like it's just below 20. So maybe 17 or 18 percent had cell phones. So landline was, we'll estimate like 84, 85%. Okay. And C, which is cell phone only and no landline, we'll say like 17 or 18%. Okay. So estimate H of 2006 and C of 2006. We did that. Okay. Then explain what each value tells us about the phones. So that tells us that in 2006, okay, 85% of homes had a landline and 17% only had a cell phone. So 85% of homes had a landline, 17% only had a cell phone in their home. Okay, so that's number one. Number two, what is the approximate solution to C of T equals 20? What is the approximate solution to C of T equals 20? So we are looking for the value of the function or the input value that gives us 20. So C is for cell phones, so that's the dashed line. Okay, so let me erase this so we can mark the graph again. So we're looking for when does the dashed graph, which is cell phones, equal 20. So that looks like it's the year 2008. So what is the approximate solution to C of T equals 20? It would be 2008. Okay. Explain what the solution means in this situation. Okay. It's we're going to use the same thing before. So in the year 2008, 20% of homes had only a cell phone. In 2008, 20% of homes had only a cell phone. Okay, so that's our answer for number two. Number three, determine if each equation is true or false. So let's see, C of 2011 equals H of 2011. So in other words, were the two functions equal Are the two functions equal in the year 2011? Clearly not. So this is a false statement. Okay? And B, C of 2015 equals H of 2015. So are the two functions equal? Do the two functions have approximately the same value in the year 2015? And we can see that they do because the graphs intersect there. So that would be a true statement. Okay. Number 4, between 2004 and 2015, so let me mark that on the graph. 2004 is here, okay, and 2015 is here, okay. Between 2004 and 2015, did the percentage of homes with landlines decrease at the same rate at which the percentage of cell phone only homes increased? Explain or show your reasoning. Okay. So what we're going to do here is we're actually going to do average rate of change. And we're going to see if we get similar values. Okay. So let's do landlines first. Let's do landline. Okay. So in 2015, all right, in 2015, the landline, which is the blue line, okay, the blue curve, looks like it's at about 50%, okay? So it's at about 50%. And in 2004, it looks like it's between 80 and 100, but slightly closer to 100. So I'm going to say it's like 92% or 93%. So between 2004 and 2015, it dropped from about 92% to 50%, right? And we're going to divide that by 2004 to 2015. That is an 11-year time span. So we're going to divide that by 11, okay? And then we'll calculate that in a moment, but we're going to do the same thing for cell phone only homes. So now we're going to look at, again, in 2015, it looks like about, again, since they were the same, about 50% of homes had only cell phones. In 2004, it looks like it was closer to 0 than it is to 20. So I'm going to estimate that I'm going to say about 5% there. All right. So between 2004 and 2015, the percentage of cell phone only looks like it went up from about 5% to about 50%. So again, we're going to subtract those and we're going to divide by 11 since that's 11 years. So let's go ahead and calculate this. All right. So I'm going to pull up Desmos on my computer here. All right. So for landlines, it would be 50 minus 92 divided by 11. 50 minus 92 divided by 11. So it dropped at a rate of about negative 3.8% per year. So negative 3.8% per year. Okay. Whereas cell phones, let's do the cell phone only. So that's going to be 50 minus 5 divided by 11. So 50 minus 5 divided by 11 is 4.1% if we round that. So that's positive 4.1%. Are they exactly the same? No. So the question said, did the percentage of homes with landlines decrease at the same rate at which the percentage of cell phone only homes increased. Well, they're not exactly the same, but 3.8% and 4.1% are really, really close to each other. It's only a 0.3% of a difference. So, in all essence, did they decrease/increase at the same rate? I'm actually going to say yes, because they were so close to each other and we were just estimating. Okay. Landlines dropped at 3.8% per year. Cell phones rose at 4.1% per year. So it's such a small difference. We're going to say yes, they did. Okay. So that is it for the back of the first page of the handout. Let's go to the last page of the handout, and then that will be it for today's lesson. Okay. So the number of people who watched a TV episode is a function of that show's episode number. Here are three functions, A, B, and C, representing three different shows. Match each description with a graph that could represent the situation described. One of the descriptions has no corresponding graph. One of the descriptions has no corresponding graph. So let's look at A. So A says this show has a very good core audience. They had a guest star in the 5th episode that brought in some new viewers, but most of them stopped watching after that. So we're looking for a graph in which there was a spike in the audience in the 5th episode. And the only one that does that, it looks like, is show C. We can see up here in episode 5, there was a spike in viewers. Okay, that could explain the guest star, and then it dropped after that. So A matches up with description A matches up with show C. Right? B, this show is one of the most popular shows, and its audience keeps increasing. Okay? Well, at first glance, okay, it appears that this could match up with show A, but if we look at the numbers, notice the numbers are the highest is around 2 million, whereas show B and show C are mostly higher than 2 million. So this would not be one of the most popular shows. So even though it looks like it's A, I'm going to hold off on concluding that for now. I'm going to wait and go through the rest here. Okay. C, this show has a small audience, but it's improving, so more people are noticing. Okay. This one, to me, this statement right here looks like it would go more with show A, because when we look at the numbers, okay, notice the first episode is less than 1 million, and the 10th episode is only at about 2 million, which is still less than most of these episodes over here. So it's got a small audience, but it is going up. So C, we're going to say, matches up with show A. Okay. And D, this show started out huge. Even though it feels like it crashed, it still has more viewers than any other show. So it started out really big, and then it had to decrease. So that's going to be this one right here. It starts off at 10 million and then drops to just under 4 million. Okay. 4 million is still higher than A, and it's still higher than show C. So that would mean D is going to match up with show B. Okay. So the one that doesn't have a corresponding graph is this one right here. Okay. So we matched all the ones that we could. Okay, 6. Which is greatest, A of 7, B of 7, or C of 7? explain what the answer tells us about the shows. So on the x-axis has to do with the episode number. So we're looking for which show had the greatest audience, the largest audience in its episode 7. So if we look at show A, episode 7 is here. So that one is between, you can see, it's between 1.5 and 2 million, okay, based on the graph. If we look at show B, episode 7 is here. That one looks really close to 4 million. So far, B is greater than A. And if we look at show C, episode 7, so episode 7 is here, that one looks like it's just a little bit bigger than 3 million. Okay, so this one is at about 3 million, a little bit bigger. B is at about 4 million. Okay, and A is between 1.5 and 2 million. So it's between 1.5 and 2 million. So which show has the greatest audience in episode 7? It's going to be show B, B of 7. Okay, so explain what the answer tells us about the show. Is it tells us for episode 7, show B had the largest audience. Okay, show B had the largest audience. Okay, number 7, last one. Sketch a graph of the viewership of the 4th TV show that did not have a matching graph. So that was the one that has a star next to it. This show is one of the most popular shows, and it keeps growing. So if we say let this be, this is obviously 0. Let's go up by 2s. 2, 4, 6, 8, 10, 12 million. Okay. So it started out high and it's growing. Okay. So it started out really high and it's still going up. So we could say that it started out here and it's continuing to increase. All right. By episode 10, it's bigger than 12 million. Okay. So does this graph match the description? Is it one of the most popular shows? Yes. Is it the highest? Yes. And does its audience keep increasing? Yes. So this would be a good sketch of the graph of the 4th show. It clearly shows that it's one of the higher ones, okay, and it's increasing. It shows that the viewership is increasing. All right, so that is it for today's lesson. What I want to do really quick is just take you through the cool down, which is in the slideshow. Okay, so on the cool down, you're going to do something similar, except in this case, you're looking at the height of a rocket. So that would be the R, and the height of a drone, which would be the D function here. So the R function is the rocket, and the D function is the drone. And you're going to answer these questions based on these graphs here. Okay, that is it for today's lesson. Have a wonderful day and have a good rest. Have a good weekend.